This video follows up from a previous one in which we were analyzing a ladder moving away from a wall, and so if you might want to go get that info if you stumbled upon this video. So we had a ladder moving, the bottom of the ladder is moving away from a wall, and in the last video we figured out the rate at which the top of the ladder was moving down the wall. And so in this process of analyzing a related rate situation, we want to make note of what we know and make note of what we want to find. This question asks us, how fast is the angle between the ladder and the ground changing at the same instant? So the same instant meaning from the last video when x was 6. So we need to introduce a new variable into this problem. We're going to call theta the angle between the ladder and the ground. And what do we know about this situation? Well, we know the rate dx dt, the rate at which the bottom of the ladder is moving away from the wall, because that was given in the previous problem. And we also know that dy dt, based on our answer from the last problem, we know that dy dt is equal to -3/2. And in this case, what we want is, it says how fast is the angle between the ladder and the ground changing. That means we want d theta dt. We want d theta dt at the instant x equals 6. All right. So we're going to model, or we've done the modeling. Now we need to write an equation. Now here you want to make sure you write an equation that's going to relate the quantity that we're interested in. So we're interested in d theta dt. So we need an equation that has theta in it. And so you've got a few options here. I might just use a simple trig function, right? The sine of theta is y/10. So that looks like one that's probably pretty promising. So you could probably use cosine or tangent as well. But I'm going to use this one. Sine of theta equals y/10. Okay, make sure you don't substitute anything into this yet. In particular, don't substitute in a y value right here. You need to differentiate both sides with respect to time, because these quantities are changing over time. They're functions of time. So I'm going to write this as 1/10 y, just because I think it'll make it easier to think of what the derivative is. Okay, so the derivative of sine of theta is cosine of theta, but theta is a function of time, so because of the chain rule, we get a times by the derivative of the inside, symbolically. And the derivative of 1/10 y is 1/10, and then times dy dt. Alright, so now we're going to substitute and solve. So we don't know, so again, ultimately we want what should happen is we should be able to substitute values in for everything except d theta dt, which is what we want. We know dy dt, because that we got from the previous video. So that's 1/10 -3/2. And there'll be a couple of things where you think it's not obvious that we know them, but we do know them. So for instance, the cosine of theta. Well, but in the diagram we have above, the cosine of theta would be an expression that's not a numerical value. But we're now, once we've taken the derivative, we sort of froze time, and we're analyzing the situation when x is 6. So when x is 6, so here's theta, that's 10. When x is 6, we know that y is 8, and this is the diagram we're going to use to figure out the cosine of theta. At this instant, the cosine of theta is equal to 6/10. So we can put in 6/10 times d theta dt. And now we've just got an algebra problem here to solve. So I'm going to times both sides by 10/6. 10, 6 times 1/10 times -3/2, and that ends up being -3/12, which is -1/4. And so what should the units be on that? Well, since it's a trig function, we're going to use radians, so that must be -1/4 radians per second. Okay, and now we interpret by writing our final answer. So we're going to say the angle, or at this instant, let's phrase it like that, at this instant, the angle between the ladder and the ground is decreasing at a rate of 1/4 radians per second. Notice the word decreasing is sort of taking care of the fact that it was a negative rate. And also note that a negative rate makes sense, right? If the top of the ladder is moving down the wall, we were expecting that the angle is getting smaller, so the rate should be negative.